All right, guys, so here's a quick video going through the lessons that we did today. We looked at the area formula of a triangle first. So this could apply to any triangle. It does not have to be a right triangle, but this is on page 12 in the Unit 8 packet. The area formula, Kurt gave us a nice little explanation of what it is. So the area of any triangle can be found as 1/2 the product, which means you're multiplying, of two side lengths and the sine of the angle in between those two known sides. So I actually wrote up above on this simplified equation here for us to use instead of what he had here written down, because he wrote down one for like each scenario where that angle would be. So you are always going to use sine. You'll never use cosine, never tangent. It is always sine of the angle in your area formula. So we're going to take a look at how this works. So again, you take 1/2 times the two side lengths you're given, and that angle that's in between, you're going to take the sine of it and also multiply that together. So let's take a look. We have find the area of triangle EFG shown below expressed to the nearest tenth of a square foot. So here's my two sides, and here's the angle that's in between. So if I'm setting up my area formula, I have 1/2 times 14 times 20 times the sine of 37. Okay, it doesn't matter whether or not 20 or 14 is A or B. You can all just plug them in whichever order you like. So we're going to plug this directly into our calculator exactly how it looks. Pull that up. So we've got 0.5. I always type in 0.5 instead of the 1/2. It makes life a lot easier. But I got 0.5 times 14 times the 20 times sine of 37. And I get 84.25. So if I'm rounding to the nearest 10, that's going to be 84.3. And my units are feet. And when we're finding area, it's going to be feet squared. Alrighty. So that's how we apply the area formula. We're going to take a look again. If you want to pause right now at exercise 2, just so that you could try it out for yourself, totally up to you, but you can keep coming along with me through this process. So we've got two triangles here. We're running our answers to the nearest tenth again. So looking at my triangles, I have my two sides. The angle is in between them. So setting this up, we have area equals 1/2 times 8 times the 15 times the sine of 75. And again, that I'm plugging directly into the calculator. So we've got 0.5 times 8 times 15 times the sine of 75. And we've got 57.95 and so on. So the 5 actually rounds the 9 up, and the 9 will then round up the 7 to an 8. So it's really 58, but because we need the 10th place, we're going to do 58.0. So we are showing that we rounded to the nearest 10th, and our units are centimeters squared. So let's take a look at B. Same situation. I have my two sides. The angle is in between. So setting up my formula, I have 1/2 times 40 times 23 times the sine of 22. And that, again, plug it directly in your calculator. We've got 0.5 times 40 times 23 times the sine of 22, which brings us to 172.3. 172.3 as our final answer, with yards squared. Okay. So we're going to take a look at one more, and then we'll move on to special right triangles. So this one we don't have a picture, so we're going to sketch it out. We have triangle RST, so I'm going to sketch out a triangle. Here's RST. RS is 11 centimeters, so here's the 11. ST is 20 centimeters. T, the measure of angle T is 50 degrees, and the measure of angle S is 32 degrees. So here's where it's tricky, because we have to figure out, okay, am I using the 50-degree angle or am I using the 32? In this case, you're looking again for the angle that is in between the two sides that you have. We have the 11 centimeters here and the 20 over here, so I need that 32-degree angle, and we're going to ignore the 50. We don't need it. So now, setting up my formula, I have 1/2 times 11 times 20 times the sine of 32. And again, plug that in your calculator. So 0.5 times the 11 times the 20 times the sine of 32. We have 58 point. This one here was asking us to round to the nearest hundredth. So it's going to be 58.29, and that is centimeters squared. Okay. So that was it on just page 12 of the area of the triangle notes. If we go over to special right triangles, that's on page 13 to 14. We honestly skipped this whole page here. There are a lot of extra notes that I was hoping to go through, but honestly, this here, we just skipped all of it, and we honestly just stuck with exercise 7. So we skipped 5 and 6 as well. And we just went right into the meat of it and looked at the two special right triangles we have. So, two special right triangles we have. We have the 45-45 right triangle, which means that the two acute angles in this triangle are both 45-degree angle, 45-degree angles. What is being shown here is essentially, if we're given one of the side lengths of this type of triangle, we're able to just figure out what the other side should be based off of what we know that's marked up here. So S just stands for side. Okay. So if these two are both the same, if you have two sides that are the same, it makes it an isosceles right triangle, which also makes sense because you have two congruent angles in there. So the two sides that make up the right angle are going to be the same measure in a 45-45 degree triangle. The hypotenuse is just the side length, but you have the square root of 2 attached to the end of it. That's all. So let's take a look at this example that's right below. For part B, we have our 45-45 degree angle. This 15 is one of the two congruent sides, so this 15 should make this side here also 15. And then the hypotenuse is going to be 15 square root of 2. That's it. That's the rule. All right? Nothing crazy. If we take a look at the 30-60-90 triangle, this one's a little more complicated. We got a lot more stuff going on. So if we look at it, H is just the hypotenuse. Okay. The side that's across from the 30-degree angle is just half of the hypotenuse. So this is half the length of the hypotenuse. Okay. This side here is another way to write it. If I cross this out, make life simpler. Another way to write it is you have 1/2 of the hypotenuse and you're attaching the square root of 3 on the end. So this is half the length of the hypotenuse with square root of 3 attached at the end. Okay. All right, so let's do some practice now. We've got part A of exercise 7. Okay, so we're given the hypotenuse here. Here's my 30-degree angle. Across from that is half the length of the hypotenuse. So half of 40 is 20. And then here is the 60-degree angle. Again, across from that is half the hypotenuse. So we have 20. And then the square root of 3 is just attached to the end. All right. Again, that's just all based off of the rules that we saw above. Last question here. We have, again, here's my 30-degree angle. Across from it, we have the 12. That is equal to half of the hypotenuse. So if we know that this 12 is half of the hypotenuse has to be double that, which makes it 24. And then the 60-degree angle, again, is half the hypotenuse, so 12, with the square root of 3. Okay. And that's all the notes that we've got. So you're going to make sure that these are all set, and then you're going to work on the homework questions. So now you guys should be able to work on all the homework questions in that homework packet. Okay.